Please make sure you have your copy of Temperature and Chemical Reaction Rates. I'm going to show you the procedures for the experiment. The procedures are on a handout at your lab bench. So when you go back to the bench, make sure to pass around the procedures so that you know what you're doing. Our goal today is to use the same chemistry that we were practicing with in the last experiment with the clock reaction to see what happens to the reaction rate when we change the temperature. We're going to use 3 different temperatures: 0 degrees, which is cold, 15 degrees, which is cool, and 30 degrees, which is warm. So one of the things we're going to have to do is we're going to have to make water baths that are at those specific temperatures and keep them constant at those temperatures during the duration of the experiment. The other thing that we'll need to do is fill up test tubes with the solutions. Now, I've made the solutions A and B a little differently from what you used. The B solution is the same. The A solution has the A mixture that you had last time, the clear cup, and it also has the C mixture that was in the red cup. So that's what's in here. And what we're going to do is we're going to put those into tubes that are labeled A and B. We're going to use the pipettes to measure very carefully up to the line for each 1 milliliter, so that you're putting 5 milliliters of the A solution in the A tubes, 5 milliliters of B solution into the B tubes. So someone could be working on that, while somebody else is working on getting the temperature of each of those 3 water baths to be at the right temperature. Now, the 0 degree one is easy. It's just going to be ice water. That's by definition 0 degrees Celsius. So we don't have to control the temperature of that one. The 15 degree one, though, it's a little bit cooler than room temperature. There's a cup of room temperature water that you can use, put a little bit of that in, and then you can take some of the water from the ice bath and put it in here and look at the thermometer and make sure that the thermometer says 15 degrees. If you need to warm it up or if you need to cool it down, use the water that you need accordingly. These 2 trays will be next to each other so that you can do that. Once you've got the temperatures in these to the correct level, then you can take the test tubes and you can put them into the water bath. That means don't pour them into the water bath. That means put them into the water bath so that they get to be the temperature of what that water bath is. So all the ones going into the 0 degree ice water will go into that cup. All the ones that are the 15 degree cool water will go into that cup right there. And we'll leave them in there for about 3 to 5 minutes until they get to the temperature of that water bath. Over here, the 30 degree water, it's a little bit warmer. So if you start with some room temperature water is about 20 something degrees. And if you need to warm it up a little bit, then you can use the cup, the beaker of warm water that's on the hot plate. It's not so hot that you can't touch it with your hands. There's a glove there in case you can't stand the heat. So just add a little bit, check to make sure that the temperature gets to 30 degrees, and then if you need to cool it down, add more of the room temperature water. If you need to warm it up, add more of this warm water. Now, if the water level in here gets to be too much, you can take some out using squeezy pipette and just put that in the sink, because when you put the test tubes in there, the water level is going to go up and you don't want it to overflow. So keep the temperature constant. Someone's got to keep their eye on this all the time, because while it's sitting there, it's going to cool off. So someone's got to keep making sure that this stays at 30 degrees. Someone keeps that one at 15 degrees. That one stays at 0 degrees all the time by definition. Once this is at 30 degrees and you've got all the tubes that you needed to make made with the A and B solutions, these go in here as well. Now, after these have been sitting in the temperature bath for about 3 to 5 minutes, then what we'll do is we'll take out a tube of A and a tube of B, and we'll pour them together into a little white cup and start the timer. When it turns blue, stop the timer and record the time, like we did before. And then when you're done, you can clean out those test tubes. Now, there's a data table that you'll keep track of your data. Each person should keep track of the data for your group. And then I'm also going to collect a group data sheet. So make sure that you put your names for your group up here and record your data here. The average you'll find by adding together the results and dividing the total by 3 to get the average. And then we'll put your average results up on the screen and calculate a class average from all of the results. And then we'll take a look and see what happens to the rate of the reaction as you increase the reaction temperature. What happens to the reaction time? How much faster or slower does it go when you change the temperature? And again, when you're all done, test tubes get poured into the sink, rinsed out, and then put back in the cups where they came from. You can dump and toss the little white cups, but please do not dump out the water baths. I'll take care of those for you. Thank you.